Hello everyone, welcome to my channel Mysterious Mathematics. In this video, we are going to talk about a problem which appeared in the Chennai Mathematical Institute Entrance Exam 2022. Now what does the problem says? Let R plus denote the set of positive real numbers for a continuous function f defined from R plus to R plus. They have defined AR, A sub R, to be the area bounded by the graph of f, x-axis from x equals 1 to r, and BR be the area denoted by the graph of x-axis of f, x-axis, x equals to r and x equals to r square. And we have to find all continuous functions f from r plus to r plus for which AR equals to BR for every positive number r. They have also given some hints. Find an equation relating fx and fx square. Consider the function x into fx. Suppose a sequence xn converges to b, where all xn and b are in the domain of a continuous function g. Then gxn must converge to g of b. For example, g of 3 to the power 1 by n converges to g of 1. So, let's get started. Now, the condition which they have given, that means AR is equals to BR, that simply means that the integral from 1 to r fx dx is the same as the integral from r to r square fx dx, and we need to find those continuous functions fx for which this is true for all r belonging to r plus. So what we'll do is, since we need to find those functions for which this is true for all r in 0 to infinity, we can differentiate both sides with respect to r, because in that way we can get rid of the integral sign. So we'll differentiate that according to the Leibniz rule. So yes, the differentiation under integration, which gives us f of r equals to 2r times f of r square minus f of r. And then we'll rearrange the terms. Now we have got f of r equals to r into f of r square. So this is the equation relating f of r and f of r square. And now we'll consider r times f of r, because they have told us to do so. We are going by the hint. So x times f of x, which is r times f of r, that is r squared times f of r square. Now this identity, the identity which we have just noticed, that is r times f of r equals to r squared times f of r square, this simplifies the problem to a great extent. Through successive iteration we get. Now you may be wondering, how does that identity simplify the problem and what do we mean by successive iteration? Not to worry, we'll just see in a minute. So that gives us r times f of r equals to r to the power 2 to the power minus n, that is 1 over 2 to the n, times f of r to the power 2 to the power minus n for all r in r plus and all non-negative integers n. The latter means the second condition, that is this is true for all non-negative integers n, tempting us to take the limiting condition. Yes, because it's true for all non-negative integers n. So easily we can take the limit both sides, and that leads to r times f of r equals to 1 times f of 1. Now here also we have used a hint which was given by them. So let the sequence xn be equals to r to the power 2 to the power minus n. So clearly xn approaches 1 as n tends to infinity, because 2 to the power minus n tends to 0, and so limit of xn will be r to the power 0, which is 1. Since r itself is not 0, is positive. So b is 1. What is b? B was the limit which was given by them, the limiting value. Now again, as the function f is continuous, because we have to find the continuous functions. So fxn will tend to f of b, which is simply f of 1. So we get r times f of r equals to 1 times f of 1. And why have we put a hash, as you can see? That also we'll see in the next slide. Now we are almost done. Again, you may be wondering how. That's very easy, because 1 times f of 1, it's f of 1. It's a constant value. So f of r will simply be f of 1 upon r. Or we can say f of x will simply be f of 1 upon x. Now f of 1, it's a constant value, so that will be simply c upon x for all x in r plus. Now in the comment section below, after watching this video, I suggest you to comment something about c. Comment means what values can c take. Can it take all positive values? Can it take all non-zero values? Now that is left to you. You write it. Okay. And here's the short but crisp and beautiful proof of how we have arrived at that identity, which was denoted by hash, which means this one. Okay. So we'll see that. Here it is. We'll substitute r square equals to t. And where will we substitute? We'll substitute in the very first slide we have seen here. R times f of r equals to r square times f of r square. This is the turning point of the problem. This almost gives away the problem. So we'll substitute r square equals to t, and that will give r times f of r equals, or t times f of r, t to the power half times f of t to the power half equals to t of tf into ft. And now we'll again let t square equals to s. And this exactly was the successive iteration which I was talking about, which was written in the previous slide. So that gives s to the half times f of s to the half equals s to the 1/4 times f of s to the 1/4. Again, we can replace s with t. So same thing. So eventually we get t into ft equals t to the power 1/4 times t to the power 1/4. Again, we'll repeat that steps, and we'll get t to the power 1 by 8 times f of t to the power 1 by 8. This will go on. So eventually we obtain that t of ft is equals to t to the power 2 to the power minus n times f of t to the power 2 to the power minus n for all t greater than 0 and all n belongs to non-negative integers. And that's what tempts us, that's what forces us to take the limit. So this was all about a problem. So finally, continuous function fx c upon x for all x in r plus, and in the comment section below write what you can deduce about the term c, what values can c take. So thank you very much for watching the video. Hope you will like it. If you like the video, hit the like button, hit the subscribe button, and share with your friends. Thank you.